The precipitation and its estimation. This is the one part of in irrigation technology, the precipitation. So you have to know the rainfall measurement, and these are the measurement should be recorded. Right, these are some measurement precipitation, and it is made that it's adopted. The student should be able to understand types of precipitation, and it's the measurement in field. Understand the concept of temporal and spatial averaging of precipitation. Apply several methods to spatially average precipitation. Understand data preparation for any water resource projects. Apply appropriate correction to data in case of missing records, errors, or inconsistencies present. When the water moisture when the water moisture is in the clouds, atmosphere gets too heavy, the water moisture falls back to the earth. This is called precipitation. I may ask the question, define the precipitation. So you have to write this, when the water moisture in the clouds gets too heavy, the water moisture falls back to the earth. The type of precipitation: the drizzle, rain, freeze rain, sleet, snow, hail. These are the types of rain. Classes of the precipitation used by the UK Meteorological uh, Office. Rain. These are the definition. Liquid water droplets between 0.5 and 7 millimeter in diameter. Drizzle, a subset of rain with the droplets less than 0.5 millimeter. Sleet, freezing raindrops, a combination of snow and rain. Snow, complex ice crystals agglomerated. Hail, the bolts of ice between 5 to 125 millimeter diameter. Right? The rainfall being the predominant form of precipitation causing stream flow, especially the flood flow in majority of rivers. Thus, in this context, rainfall is used synonymously with precipitation. The rain, it is precipitation in the form of rain, in the form of water drops of drops of size between 0.5 millimeter to 7 millimeter. The rainfall is classified to light rain, moderate rain, the heavy rain. If the intensity is raised to 2.5 millimeter per hour. The moderated rain, if the intensity is 2.5 millimeter per hour to 7.5 millimeter hour. Heavy rain above. These are the rainfall classification. The measurement units. The amount of precipitation rain, it is measured total depth of rainfall over an area in one day. Intensity of precipitation millimeter per hour or inch per hour. It is amount of precipitation at place per unit time rain rate. It is expressed by millimeter per hour or inch per hour. Measurement of precipitation. Why do we need to measure rainfall? These are the important things. I may ask the question, why do we need to? Is agriculture, but to plant in certain areas, where and when to plant, when to harvest. Horticulture and viticulture, how and when to irrigate, engineers to design structures for runoff control, stormwater drains, bridges, etc. Scientists, hydrological modeling of catchments. The method of measuring rainfall. Instruments for measuring precipitation include rain gauges and snow gauges, and various types are manufactured according to the purpose at hand. Rain gauges are classified non-recordings and recording types. Instrument used to collect, measure the precipitation is called rain gauge, and the location and at which rain gauge is located is called gauging station. Measurement of precipitation, non-recording manual type, often have one funnel opening into the cylinder gauge, come in variety of shapes and size, calculate the rainfall by dividing the volume of water collected by area of the opening of the cap. This is the recording manual type. This one. These are the measurement of precipitation instrument. The measurement of precipitation recording or automatic type, tipping bucket gauges, weighing type gauges, float recording gauges. Tipping bucket rain gauge, the bucket tips when precipitation of 0.2 millimeter, 0.5 millimeter, 1 millimeter has been collected. Each tip is recorded by data logger. The weather station, the measurement of precipitation, recording, automatic type. Weather stations records rainfall but also evaporation air, pressure, temperature, wind speed and wind direction used to estimate evapotranspiration. Radar, ground-based radar equipment can be used to determine how much rain falling and where it is the heaviest. So important thing. The radar, the ground-based radar equipment can be used to determine how much rain is falling and where it is the heaviest. The measurement of precipitation, recording types, weather station. The recording types, radar. The measurement of precipitation rain gauge network, since the catching area of the rain gauge is very small as compared to aerial extent storm to get a representative picture of storm over catchment. The number of rain gauges should be as large as possible. Catchment area per gauge should be small. There are several factors to be considered to restrict the number of gauges. The World Meteorological Organization recommendation in flood regions, temperature, Mediterranean and tropical zones, ideal station 600 to 900 km per square, acceptable. First station 900 to 3000 km square in mountain regions of temperature, Mediterranean and tropical zones, ideal. First station 400 to 250 km square, acceptable. The station for 250 to 1000 kilometers square in arid and polar zone. Station so 500 to 10,000 kilometer per square. 10 percentage of rain gauges should be self-recording to know intensity of rainfall. The measurement of precipitation, rain gauge network, placement of rain gauges. Gauges are affected by wind pattern, areas, trees, the gauge itself. Therefore, it is important to have the gauge located and positioned properly. The rain gauges should be 1 meter above ground level is standard. All gauges in catchment should be the same height to 2 times distance away from an isolated object such as a tree or building, or in forest clearing, the radius at least the tree height place the gauge in canopy level. So we can locate it here at canopy level. Normally, canopy means the sun side of the building, right? We can place the rain gauges. Shielded to protect gauge in windy sides. So, if obstructions are numerous, they are reduce the wind speed, turbulence, and eddy. The measurement of rain gauge network, wind gauges without shield, wind gauge, and with shield. These are the picture for rain gauge with wind shield. So we know why we need to measure the rain. Earlier, this is an important parameter in irrigation technology. If you go to an irrigation department too, as a technical officer, so you have to know about the rainfall measurement. And you have to keep the records for past 10 years, so that's rainfall data. So we can identify the flood when it comes flood and most affected area by during the heavy flood. So each of the information is available in irrigation department and also in meteorological department. Okay. Measurement of precipitation. The for sloping ground, the gauge should be placed with the opening parallel to the ground. The rainfall catchment volume is then divided the opening area that the rain can enter. These are the measurement of precipitation source of errors. These are the source of errors. I may ask the questions. What are the source of errors in measurement of the precipitation? So you can write. I may ask for 1, 2, 3, 4, 5, 4, 5, 9. Write measurement of precipitation, source of errors. Right? Precipitation of data. Before using rainfall data for any analysis, it is necessary to check the record for missing data and no consistency of data. Inconsistency in rainfall data might root from change of gauge location, change of gauge type, change of gauge environment, change of gauge observer, change of gauge climate. So I asked the question, write the methods can be used to estimate the missing precipitation is for 4 marks. So you have to write this one, the station average method, normal ratio method, inverse distance weighing regression. Okay. The precipitation of data, missing data, station average method, Px is equal to 1 by n, sigma n, I is equal to 1 pi. This is the equation. Px is the missing precipitation value for station X, P1, P2, Pn are precipitation values at the adjacent station for the same period. N is the number of nearby stations. This method is used when 10% variation in annual precipitation at station X lies within annual precipitation of surrounding adjacent stations. Find out the missing storm precipitation data of station X given following table using station. These are some calculation. We have to find the missing stations. So average this one. Storm precipitation. Storm precipitation. The meaning. What's the meaning? There's a storm precipitation. The precipitation is happened during the storm or cyclone. Is a little bit same meaning. So annual precipitation ranges. So annual means the 12 months average. This one. So storm precipitation 3.8 this one. So we have to find the missing station. X storm how much storm precipitation. This is the average method. This is equation 1 by n sigma is in here is equal to half 1 by 4 3.8 this one 3 point and 3.25 4.6. So you have to add the storm precipitation values divided by number of stations. N means number of stations. Okay, so you can get the value. Then precipitation data using data normal ratio method. This is the Px by index is equal to 1 by n, P1 divided by n1, P2 divided by n2. The Px is the missing precipitation value for station X certain time period. P1, P2, n are precipitation values. Adjacent station for the same period. Nx is the long-term annual average precipitation at station X. N1, N2, N is the long-term precipitation for neighboring stations. N is the number of adjacent stations. We can see the calculation. The preparation of data missing. Find out the missing storm precipitation data of station X given in the following table. Is the data the test the normal annual precipitation at X 10 percentage of 30.6.1. What is the question? Find out the missing storm precipitation X given the following. 3.6 plus this one and since the annual precipitation of adjacent station does not within the 10 percentage to station. Averaging method cannot be used instead of normal ratio method will be used. This is the question. This is the find out the missing data, missing storm precipitation exit station averaging method. Storm. What about 10 percentage variation check from annual precipitation? Then another question. Find out the missing storm precipitation data of station X given in following. Station Find out the missing storm precipitation data of stations X given in the following table. Storm precipitation 1 3.8 2 is equal to this one. We can use this following equations. So P1 3.8 inches, P2 3.25, and P3 is 4.6, P4 is one. So we have to find the Px. N value we know, annual precipitation. So we can substitute these values Px divided in x 1 by n, P1 divided by n1, P2 divided by n2 plus Pn divided by n. Px divided by nx 1 by n, P1 divided by, these are the equation. You can substitute this value. So you can find this Px value, right? The precipitation of data missing the station average method. The precipitation stations exposed in operative for part of month during the storm occurred. The respective storm totals. Three surrounding station A, B, C were 98, 80 and 110 millimeter. The normal annual precipitation amount at station X, A, B and C are respectively 800, 1008, 8442 and 1018. Estimate the storm precipitation. So you have, first of all you have to understand what's the meaning of storm precipitation and annual precipitation. They are given some data. Firstly, they give storm data 98 millimeter and PC is equal to 110 PX. The normal annual precipitation at X and AB so you can estimate the storm precipitation for X. Some this one, the distance from gauge with missing data to neighboring gauges, weight of distance, these are some formulas. Preparation of data, missing data, regression. Px is missing precipitation value for station X for certain time periods. P1, P2 and Pn are precipitation values neighboring station for the same period. B note, Bn are coefficients calculated by least scarce method in number of nearby gauges. The precipitation of data consistent data double mass curve techniques take group 5 to 10 base station in neighborhood of the problem station X is selected. Arrange the data of station X rainfall and average of the neighboring stations in reverse chronological order from recent to old record. Accumulate the precipitation of stations sigma bx and the average values the group based stations starting from the latest record. Plot the sigma px against sigma average as shown on the next figure. A decided break in slope of the resulting plot observed. This is the double mass curve. So node 0.5112 this one, the accumulated annual rainfall accumulated. Accumulated annual rainfall neighboring the stations. This one. Some of the questions. Annual rainfall station extend the average method of annual rainfall to 25 surrounding based stations are given below for period of 36 years starting from 1941. The year rainfall, the question that takes average rainfall year, rainfall at takes average rainfall at takes average rainfall at base station. These are the given data. Check the whether data exists consistent. In which year of change indicated? Compute the mean rainfall for station uh, at present site for given 36 year for year period. First with adjacent and secondly with the data adjusted for the change in region. Compute the adjusted annual rainfall at station X for affected period. This is the cumulative rainfall. This is the cumulative average rainfall at the base station. Cumulative means you have to add this one 163 plus 160 119. How much? So you can add here, add here. So cumulative method. This is the rainfall base station. So you can understand the accumulate average method. So you can add that and you can draw the graph. This 1975. The precipitation of consistency of data as the double mass curve is not having the uniform slope, it can be concluded the record station is not consistent. Since there is break slope of double mass curve in here, it may be said the data at stations experience prior to 1953 is inconsistent and needs adjustment. So the mean annual rainfall is without adjustment. So the foam column table 5.5 36-year rainfall station 6 without adjustment 39.3 centimeter. The mean annual rainfall at takes without adjustment 39.53 divided by 6 36. The double mass curve figure 5.26 cumulative rainfall station X for 30 years after correction is equal to 34 this one. The slope of adjust mass curve for the affected period of this one to this one, that is the slope of the line CB dash 0.85. The slope of the unadjusted mass curve, that is slope of the line CB is equal to 1.17. Therefore, correction factor for adjustment 0.85 divided by 1.17. The adjusted rainfalls at Station Expo the period 1941 to 1952 are given below. Observed rainfall index, the adjusted rainfall index P is equal 1941 163 this P dash. So we can find this one value. adjusted rainfall. The temporal and spatial variation rainfall. Rainfall varies created by the time and phases with respect to temporal variation with the spatial variation. Temporal variation may be defined hourly and daily, monthly, seasonal variation. Temporal and spatial variation of rainfall. Long-term precipitations variation at ARBA means is total years annual rainfall. Temporal and spatial variation of the rainfall. This one, the rainfall annual totals. This one, right? Temporal averaging of precipitation, storm rainfall precipitation. It is the precipitation of particular storm or rainfall event. Daily rainfall. The amount of rainfall accumulated one day at place mathematically. Where P is the daily rainfall and B is the storm rainfall during the given day. Monthly rainfall. The amount of rainfall accumulated one month at a place mathematically. Where P is the rainfall is precipitation during the given month. Annual rainfall. The amount of rainfall accumulated 1 year at the place mathematically. Where P cons is annual rainfall, P day is the daily rainfall. Average rainfall for n years. It is the arithmetic average of annual precipitation for n years. Rain gauges stations mathematically. P average sigma Pi I is n to n divided by n. Where P average is rainfall for n years and Pi is the annual rainfall for first year. This is the climatic data for Dubai. So March, January, climate data. Okay. Uh, the rain gauges rainfall represent only point sampling of area distribution of the storm. The important rainfall for the hydrological analysis is rainfall over in areas such as over the catchment. To convert the point rainfall values, various stations into average value over a catchment, the following methods are used. Arithmetic mean method, method of Thiessen polygon method. I may ask the questions. To convert the point of rainfall values various stations to average value over a catchment, the following methods are. So I may ask how to compute the rainfall values at catchment. What are the methods followed? So you can write the arithmetic mean. The These are the method. The method of Thiessen polygon method, the isocatal method. Methods of spatial averaging rainfall data, arithmetic mean method. When the area is physically and climatically homogeneous and required accuracy is involved, the average rainfall for basin can be obtained as the arithmetic mean of the PI values recorded at various stations, applicable rarely for practical purpose. P1, P2, P3, PI, and PN. The method of polygon method, the recent polygons consist attributing to catch each station and influence zones in which it is considered that the rainfall is equivalent to the of the stations. The influence zones are represented by convex polygon. These polygons are obtained using the meters of segments which link each station to the closest neighboring stations. Okay, the methods of spatial rainfall data, Thiessen polygon method. We have to make the polygon, right? These are the area. Decent polygon में B bar is equal to P1 into A1 plus P2 into A2 plus P1 divided by this one. Generally, M station P bar is equal to sigma IA PIA. A total is PI is equal to 1 M PI AI divided by A. In a catchment area, approximately the circle. So catchment area means the water, the rainwater is coming to the particular portion, to a dam or particular place. That path is called catchment area. So you have to understand what's the meaning of catchment. Approximately by a circle of diameter 100 km, 4 rainfall stations are situated inside the catchment, and one station is outside. It is neighborhood. The coordinates of the center of the catchment and of the 5 stations are given below. Also given the annual precipitation recorded by 5 stations in 1980. Determine the average rainfall participation and each and mean method. So we have to find what they ask. The coordination of the center of the catchment and of the 5 stations are given below. Also given annual precipitation recorded by the 5 station in 1918. Determine the average annual precipitation. These are mean method. Station 1, 2, 3, 4, 5. Coordinates 30, 30, 80, 70, 80. This one. Precipitation. These are the dates. So you have to find this one. The solution, the catchment area is road scale and stations marked the triangle perpendicular bisectors of each road. This station polygon area enclosing each station. The identified it may be noted station 1. The problem does not have any area influence in the catchment. The area of various decision Thesian polygons are determined either planimeter or by placing overhead. The boundary area ABCD, these are the area fractional, this one A divided by A, rainfall PN, the weight. So you can find the mean precipitation. Actually, you know the planimeter you use in the surveying. So you have the practical also plan meter. You can find the area of given map. Normally you can see the atlas map. Consider the atlas map. They make they put a scale, but we can measure the actual area with the using of parameter with multiplying of scale. This is the thing. Planimeter. The surveying instrument. One of the surveying instrument is the planimeter. So we can measure the actual area. And isohedral is line is joining points equal rainfall magnitude. Okay. P1, P2, P3, Pn values are isoheads. A1, A2, A3 the inlet in the isoheads area respectively. The total catchment area. P bar the mean precipitation over the catchment. P bar is equal to A1 into P1 plus P2 divided by 2 plus A2 into P2 plus P3 divided by 2. This is the annual, the average method, a total. The isohedral method, the station isoheads are centimeter 12, area 30 kilometers square, 12 to 10, and 10 to 8, 8 to 6, and this is the area. You can find this one. The solution for first consistent station surrounded by a closed isohead precipitation value 12 centimeters is taken. For other areas, the mean of the two bounding isoheads are taken. average value of P. P is equal to Pi divided by Pn divided by 2. Area is equal to 3. Fraction total area AI divided by total P average. This is 12, 12, 30. AI divided by 8 total. So you can find the total. Mean precipitation 8.844 centimeter. Okay. ISOHEAD method, the other mapping programs, Surfer GIS program ArcView, can be used to map rainfall at the different measurement locations. Okay. This is the hydrograph, rainfall intensity versus time, the total depth, hydrograph storm. The accumulated precipitation, millimeter. The first storm 60 millimeter, second storm 34 millimeter. So example, the mass curve rainfall storm total to 270 minutes. So the hydrograph of the storm 30 minutes. Time step. So we have to convert to this one. This is the scene start time. Time is one. The accumulated rainfalls note 6, 8. So increment depth 30 interval 30 millimeter. So we can multiply subtract 6, 12, 3, 15, 36 minus 12, 21, 40, 54 minus 300. So rainfall intensity you have to multiply by 2. Why? Interval we know is 30 minutes. Because they give the data the mass curve storm to 270 minutes. So incremental depth of 30 minutes. So rainfall intensity millimeter per hour. This one for 30 minutes. So normally this is the standard version. The rainfall intensity means we have to calculate the rainfall for 1 hour. So this is time step and rainfall intensity. So for node 6, this one above one and final one. So you can draw the hydrograph. The return period, the average length of time, years, and one given magnitude be equally or exceeded. For example, if the rainfall with the 50-year return period location is one, the probability occurrence, the event specified probability that of the specified magnitude will be equal or exceeded during the 1 year. The probability analyzed may be made either empirical by analytical methods. A simple empirical technique is arrange the given annual extreme series descending order magnitude to assign other order. Thus, for the first entry and for second, the probability of P of an event equivalent to or exceed Bible formula. P is equal to M divided by N plus 1. So T is equal to 1 by P, this one. The above equation empirical, there are several another empirical equation available calculation. This one here, the record annual rainfall season covering period of 22 years is given below. Estimated the annual rainfall with a return period of 10 years and 23 years. What would be a probability of annual rainfall magnitude equal to exceeding 100 centimeter. Whatever they ask, they estimate the annual rainfall with a return period of 10 years. So, first of all, you have to understand what's the meaning of return period. Return period means the average length of the time years for an event, flood or rainfall of event magnitude to be the equal or exceeded. For example, if the rainfall is 50-year return period at a given location is 200 millimeter, this is just another way of saying that rainfall 200 millimeter or greater should occur at the location on the average only once every 50 years. Probability occurrence of an so you have to understand the average length of the time in years for an event magnitude to be equal or exceed, right? Probability analysis may be either empirical or by analytical method. The annual rain is one year. Estimate the annual rainfall with a return period of 10 years and 23 years. What would be probability of the annual rainfall magnitude to exceeding 100 centimeter? So annual rainfall is equal to 160 m 160. Estimate the rainfall and return period of 100 years. The record of the annual rainfall, the 160 is one. How to come 136 and 160, 140. This is the IDF, the frequency relationship IDF curve. In many designs problems related to watershed such as runoff, disposal, erosion control, highway construction, culvert design, it is necessary to know the rainfall intensity, cities different duration and different return period. Okay, I is equal to intensity per hour, K it's in constant and given catchment duration hour. Typical IDF curve intensity 8 centimeter per hour, duration per hour. Right. This is the intensity measurement of uh, average rainfall over an area. It is the amount of precipitation which can be assumed as the uniform